Everyone. We all know about the Titanic, the British passenger line, which sunk after striking an iceberg back in 1912. There were many who lost their lives, and only some who could come out alive. We, the students of DB2, were given an assignment as part of big data analytics, in which we were given a training and test data set, and we had to predict who would survive a similar scenario. What if we were in the Titanic? Who among us would survive and who would not? So let's cover what we mainly cover in this project. The first and most important step is to clean the data. So to get a higher accuracy and to get better predictions, it is important that we feed clean data. I would be covering in the next few slides how we went about cleaning our data. After that, we had to train the model. We were given a training data set, as I mentioned before, and we tried to train this in 3 different scenarios. We tried the decision tree, we tried the ensemble, and then the deep net. After this, we tested our data set with batch prediction to predict who among us would survive and not. After this, we would have a conclusion in which I would be covering the main insights we obtained as a result of doing this project and what we really learned. This presentation also has a lot of data which we gathered during our project. So why to clean data? Why is it so important? So the type of input data you give, the type of output you get. So to get better accuracy and to get better results, it is important that you feed in clean data. It is very important to ensure that there are no duplicate records, there are no empty records, and also to ensure that there are no outliers. In case if there are any outliers, it is important to ensure you remove it. So let's cover on how we try to clean our data. So the first step we did was we tried to test the accuracy of the base model, which is the training data set we were given. When we tested this in Big ML, we got an accuracy of 73.4%. We observed that there were no outliers, because of which we had no outliers to remove. And then when we did an ensemble, we noticed that the P class and the family members were the most important factors to predict whether a passenger on board would survive or not. The P class was a column which basically contains information about the part of the ship the passenger was in, as in the class of the ship. And the family members were indicated by 2 columns in our data set, which included the number of siblings, as well as the number of parents and other family members on board. So our first step to clean the data, we went through our data and we observed that there were many empty records. We noticed that most of the empty records had the cabin field empty. So what did we do? We decided to delete this. We could not afford to have empty records in our data set, or the model would not predict accurately. So this is what we did. We deleted it, and as you can see, we got an accuracy of 65.5% and a precision of 80.2% and a recall of 59.2%. And we did this using decision tree. The next step, we also observed that there were many empty records which had the age column empty. Now we had 2 choices. We could either delete the empty records which had the age column empty, or we could calculate the mean age and fill in these empty records. We decided to go with the second choice. So what we did is we calculated the average age of men and women based on each class, and accordingly we filled in these empty records. On testing this in Big ML using decision tree again, we got an accuracy of 70.1%, as you can see, along with the precision of 64.9% and a recall of 83.7%. So you can see this actually increased compared to the last step, which is a good sign. Now the next step. The next thing we did was, as we noticed before, we felt that the family column plays a major role in indicating whether a passenger would survive or not. So to make the data more clear for our model, what we did is we created an additional column called family. This would have binary values. It would have one, we fed in values. It would have one if the passenger on board had family members, and zero if they did not have family members on board. This was calculated based on two other columns in our data set, which were siblings and the parents and other family members on board. After testing this data set in Big ML, we got an accuracy of 69.6%, as you can see, with a precision of 81.8% and a recall of 65.8%. We could see this actually led to a decrease in the accuracy, but we felt this was an important step to make our data more clear for that model. So to summarize our entire cleaning process, we use the decision tree for each step. And as you can see, after we started our cleaning process, we got the highest accuracy after deleting the cabin field and after calculating the average age, which is 70.1%, because of which we decided to go ahead with this data set to further train our models. Now over to Gilles, who will explain to you the different type of models we try to train. And he would also cover the pros and cons of each model.
Perfect. Thank you, Deepika. So which models did we use and what are the pros and cons of these models? Basically, we used three different models: the decision tree, the ensemble or the random forest, and the DeepNet model. First of all, the decision tree. What is a decision tree? The decision tree is a model which shows the possible decisions and their possible consequences. What is good about this model is that it's very simple and easy to understand the possible consequences, as you just have to follow the multiple paths of the decision tree. A slightly negative aspect of the decision tree is the fact that it's not very competitive in terms of accuracy. And we saw that in our model as well, that we got a higher accuracy with the ensemble and the DeepNet. The ensemble or the random forest is actually, it consists of many decision trees. For that reason, it's often more accurate. And it works also well with unbalanced data. A negative aspect of the random forest is that it can be complex to interpret. And then the last model that we used is a DeepNet, or the neural network. And it is actually a set of algorithms that is designed to recognize certain patterns. Why is it useful to use it? Because it can learn or it can detect certain patterns in unstructured data with a large input. A slightly negative aspect of it is that it's often hard to detect which independent variable influences in which degree the dependent variables. And then let's look at our results. What were our results and what is the significance of those results? So first of all, what is the significance of our three results? So we calculated each time the accuracy, the precision, and the recall. What is accuracy? The accuracy calculates the rate between the predicted and the actual survivors. So it divides the true positives and the true negatives with the true positives, true negatives, and the false positives, false negatives as well. The precision calculates how accurate the positive predictions are. It's actually the prediction to survive. And then the recall calculates the percentage of survivors we predicted from upfront. If we then take a look at our results in the testing phase, with the decision tree, we got an accuracy of 70%, a precision of almost 65%, and a recall of 83.7%. When we combined multiple decision trees together with our ensemble, we got a slightly higher accuracy to 74% almost. And what is very significant here is that with our DeepNet, we got almost an accuracy of 81% and a recall of almost 95%. So for this reason, when did our group survive the Titanic, we used the model DeepNet as well to predict it for our group, as we got the highest accuracy with that model. We then put some random variables in it, such as the P class, where we did 1, 2, 3. And another random was if we had some siblings or some parents. But then other variables, we try to make it real life, such as the age and the sex. What is noticeable here is that both Andreina and Reiner did not survive the Titanic. We can see also that both of them did not have any family on board. So this is something we noticed.
So as you can see, we went through a lot of steps. And what did we finally learn? What are the main insights we gained as part of doing this project? First thing, we understood cleaning is a very crucial step. As you can see, as part of our project, there was not much increase in accuracy. However, it was a very important step to feed clean data into the model. Then we trained the data using 3 different models or 3 different scenarios. We used the decision tree, the ensemble, and DeepNet. And we noticed that DeepNet gave us the highest accuracy, and that is the reason we used that to further batch predict whether our members would survive or not. We concluded that P class and family members were the most important parameters. This family members included siblings, parents, and other family members on board. And since DeepNet gave us the highest accuracy, this is what we used further to predict who survives. So thank you, and hope that you survive the Titanic.